it's return of the BoogieBot. So remember, we've looked at BoogieBot before where we had a list of functions, but now BoogieBot is a type. So we can create an instance like this where we say let leftBot equals BoogieBot. And so because it's an instance, we can have more than one. So let rightBot equal BoogieBot. All right, let's have a dance off. So we now have a stage type, Boogie Stage. It can do the recording. It will give each a name, and then we add it to the stage, and then we can go through the dances. So let's take a look at the assistant editor and make sure we can see the dancing. I want to go ahead and shrink down the results sidebar. Awesome. So update the instance methods of BoogieBot to build a fun dance-off between the two robots. The auto-completion pop-up will help you out, and there's no danger in calling left arm up if you don't already have a working robot. All right, I'm going to add a few. You can do whatever you'd like, but I'm just going to do a couple. Jump up, left bot dot jump down, and right bot dot left arm up, and then we're going to jump. Let's try that. Bot dot jump up, and then jump down, and then finally put the arm down. Left arm down. Awesome. Let's check it out. Cool. So have fun with that, and it makes it a lot easier because now notice you can see all of the available methods when you start typing. So you see the autocomplete. We can do right, left, all sorts of stuff. Okay, let's take a look at the next exercise, Treehouse Pulley. So on this exercise, we're going to use code to decide whether it's safe to add items to a basket that will be delivered to your treehouse by a pulley. Create 3 constants for items of different weights that you'd like to bring up to your fort. 1 less than 100, 1 between 100 and 1,000, and 1 over 1,000. I want to go ahead and close the assistant editor. And let me open up sidebar. Okay, well, let's see. I need, for my fort, I need pizza, for sure. Let's go with 50 pounds or whatever that is. We'll just go with 50. It's a good number. All right, all that pizza is going to make me thirsty, so we need some soda, and probably need a lot of soda. So let's say 150. And finally, what else? We need a TV. Yeah, we do. Or I guess you go lowercase. So we need a TV. And that TV is kind of heavy. Okay. Now, a lightweight treehouse pulley is already created below, but you've decided that you want to be able to lift, say, a small horse or piano or TV up to your fort. So you're installing a second pulley with a much bigger basket. Create a second pulley that has a higher capacity and can hold at least 10 times the weight of the rickety rope. All right. Let's call it strong rope. And we're going to say treehouse pulley. And the weight capacity, oh, it's going to be like 2,000. Look at that. That ought to do it. All right, now use the treehouse pulley type's add load to basket method to add the items you defined above. Add 3 of the lightest items, 2 of the middle, and 1 of the heaviest. Add the items to the lightweight pulley first, using the can handle additional load method to check whether the item would overload the pulley. Then move on to your stronger pulley when the first is fully loaded. Okay, so now that means first we want to take our rickety rope and we want to say add load to basket. And we're going to add pizza. Let's just see. So we have one pizza. Okay, now notice here we've got an error. And what does that error say? Add load to basket is inaccessible due to internal protection level. Well, that's no good. So I saw this before, and it appears that this particular playground has a bug in it. Has a couple of bugs, in fact. I looked online, and currently in the source code that we've downloaded from the book, it has this buggy code. There's another problem. Let me show you what it is. If you call the method, so rickety rope dot can handle, and then we pass in a value, say like 20. Notice the problem here. Let me comment out this one. Notice this problem says false. Now this is wrong, because the question is when you call this method, you say can handle additional load. Well, right now the capacity is 200, and we're only adding 20, and it's returning false. So this is another bug with this code. So the way to see the source code for the playground is to open the navigator. So if we go over here and we're going to show the navigator, then we open up this and notice how these are all the different playground pages. So we have freight elevator, and we open that up, and now we have sources, and guess what? Here's freight elevator.swift. Okay, now there's a lot of code here, and you don't have to understand everything, but I want to call out a few things that are currently causing problems. Let's look at this can handle additional load. Notice that it says if current weight plus load is greater than weight capacity, return true. Now, the problem with that is the function is can handle additional load. Well, if the current weight plus the load is greater than the weight capacity, that means it can't handle more. This needs to be switched. This needs to be less than. So go ahead and change that, and if we go back to the page by clicking here, now this is going to reload. Notice how this changed to true. Rickety rope.can handle additional load equals true. Let's go ahead and try it again. Like if I said 200, then the weight capacity is 200, and it returns false because it ends up being incorrect. Let's go back to the source and let's verify a few things. Okay. Current weight plus load equals weight capacity. Is less than weight capacity, return true. Weight capacity is what gets initialized here. All right, now the next problem is this mutating function, add load to basket. The problem is these are set as internal methods, which means we can't call them publicly, and it's throwing an error. So let's change this to public for a second, and I'm going to press Command S to save this. Now we have an error, which is to be expected because it says make self is mutable, left side of operator isn't mutable. So this current weight is currently saying it's not mutable, self is immutable. Mark mutating to make self mutatable. Let's try. Okay, so here's the solution. Let's try see if that fixed it. Okay, we need to make that public. Let's try that. Let's see if this solves our problem. Because we need, if we add the public keyword, that means we can call it outside of with the instance. We can call these methods from the instance. So let's try that again. Let's go back to the source, to the playground. Now let me uncomment this guy right here. Let's see if this solved it or not. Immutable value. Rickety rope is a let constant. Okay, so now let's change this to var. Let's change this to var. See if that does it. Exercise, missing argument label load weight in call. Oh, okay, well, let's try it. Load weight. Pizza. Okay, so now we're starting to work. Okay, I think we've got it. We've made it so that we can access this method. And so if I call the method again and I say rickety rope, notice the autocomplete now works. See that? Autocomplete. That's what we want because we've made those methods public. Okay. The next thing, let's go ahead and continue. I'm going to delete this line and I'll show you when we're going to use it. All right, let's go back to what we're trying to accomplish. First, add 3 of the lightest item, 2 of the middleweight item, and 1 of the heaviest. So 3 of the lightest. Now, the way this works, we could say, so first we add the first item, which is 50. Now, we know that 50 is less than 200. We can keep adding, but the code needs to check whether you can continue adding code. So one way to do that is to use the if statement. We can say if rickety rope dot can handle additional load of pizza, then we say rickety rope dot add load to basket, and we say pizza. Okay, so check that out. So first thing we did is we added the pizza, then we checked, can we add another one? And then if true, then we go ahead and add it, and it is true, we can add it. Then we could do the else if, or we could do, let's do another if statement below it. So let's just say if rickety rope dot can handle additional load of pizza, because we need 1 more pizza. Then we say rickety rope dot add load to basket pizza. Okay, so right now we've added 1, 2, and 3 pizzas. Now the question is, okay, it says add 3 of the lightest, 2 of the middleweight item. So now the question is, if soda, so we've added 3 pizza, now we need 2 soda. So the next statement is we say if rickety rope dot can handle additional load of soda, then we say rickety rope dot add load to basket, and we say soda. Else, and we're kind of cheating here because I'm saying if it can, keep going. If not, then we need to start using our stronger rope, right? Then we say strong rope dot add load to basket soda. All right, now the question is, so we have added rickety rope. Let's see, we've added 1 soda to the strong rope. Notice how when we asked the question, can handle additional load of soda, and it returned it wasn't true. It was false. It couldn't take more. So now we use the strong rope. All right, now we say if strong rope can handle additional load of soda, then we say strong rope dot add load to basket soda. All right, now we know that it's current. Now here's the question. We've added 2 items. Now the question is, can we add one of the heaviest? So we ask the question, if strong rope dot can handle additional load is TV, then we add it. Add load to basket, TV. Else, if it can't, then let's just print too much for the strong rope. All right, let's see what it has. Looks like it works because notice capacity and current load 1500. So it was able to carry it. Very good. All right, so with a few modifications to the source code, then we were able to make this work. All right, let's check out the next exercise, identity. I'm going to go ahead and hide the navigator because we don't need to worry about that anymore. All right, what does it really mean for an instance value to have its own identity? Create a variable for my plans initialized to a string describing your evening plans. Create a second variable for friend plans, but initialize it to my plans. Your friend takes less initiative than you. All right, below the declaration of friend plans, update my plans by using the addition operator to add one more activity. Check the values of my plans and friend plans. Are they the same or different? All right, let's create our variables. So these are going to be var because they're going to change. So my plans equal eat dinner, watch a movie, and then var friend plans equal my plans. So that's what that means when it says initialize it to my plans. That means I'm saying friend plans equal my plans. All right, now below friend plans, update my plans by adding the plus to do one more thing. Okay, so my plans plus get ice cream. We'll add a comma and a space. Oh, I guess it says update my plans here. So I can cut that and paste that here. Anyway, we're all good. Update my plans here. All right, so let's see what it says. Eat dinner, watch a movie, get ice cream. Awesome. Okay, now the question is, what about my friend plans? So let's just type friend plans and then my plans. Let's compare the two. Okay. I should have I needed to make this, this didn't update. Why didn't this update? Well, because I didn't set the value. I didn't change my plans to equal it. So I can do two things. I can say my plans equals my plans plus the new string, and notice how it changes. Or I could shortcut this and say plus equals. So what happened was this call right here will change the original value of my plans. Now notice the point here is that these are now different. See, initially we said friend plans equals my plans, but because this is a different instance, when I change my plans, it does not change friend plans. See that? All right, let's check it out. Create a function, add dance, that takes a string, appends a phrase about dancing like, and then we dance, or but no dancing, according to your taste, and return the new string. Call add dance function on my plans and assign the result to friend plans. Okay, so here's our function. We're going to say function add dance, and then it's going to take a type of, we're just going to call it person, or I should say, we'll call this new plans, which is of type string, and then we return. We do the return by doing the text arrow string. Now we're going to return new plans plus equals, and then we dance. A little space. Okay, now notice something here. There's an error. Let's look at this. It says new plans is a let constant. Okay, when you're dealing with an argument in a function, this is treated as a let constant. So we can't manipulate that because we can't do the plus equals because it's not a variable. So we can fix that by creating a variable. So we can say var updated plans equals new plans plus new plans plus then the phrase, then we dance, and then we return. I'm going to delete this, and then we return updated plans. Okay. Okay, now it's saying you could use a let instead. It prefers a constant instead of a variable. Now, the reason why, and I realized this as I typed it, the reason why we don't need to do, we can either do the plus equals if it's a variable, or we just do the plus to return it. Now, someone is thinking, well, Brent, why couldn't you just return new plans plus the string? And that's actually what I probably should have done, because that was the mistake I made the first time. So let's just back that up, and let's fix this by saying return new plans plus the string, and then we dance. All right, we've gone in circles, but the difference is we didn't say plus equals. Plus equals, remember, modifies the existing variable, and if it's a constant, then you can't modify it because it's immutable. But a variable is mutable, meaning you can change it. When you say plus equals, you're changing the existing value. When we say new plans plus and then we dance, what we're doing is we're passing a string. We're not changing new plans. We're just changing a string that includes what new plans were. All right, now let's finish this off and call add dance function on my plans assigned to the result to friend plans. Okay, so we say friend plans equal add dance my plans. Okay. So as you can see, now friend plans, let's take a look at this. Check this out. We say friend plans and we say my plans. Let's see where we are. Now notice that friend plans is updated and my plans have not changed. All right, we just did that up here. But there you go. So that's how things are. An instance of things can be changed. They're not identical, right? An instance is its own thing. So if you modify an instance, it'll be different than all the other instances. All right. Thanks for watching. Be sure to subscribe and check out the next video.